Assalamualaikum students. I hope you all are doing. So today we are continuing to our previous topic, types of matrices. In the previous lecture, we learned four types of. Today I'm going to other four types of. So number one is the horizontal matrix. Very easy. Let me first the definition. A matrix of order m into n is a horizontal matrix if n is greater than m. Let me show you horizontal difference between horizontal and vertical. Horizontal and vertical. Okay, so let us map definition to horizontal. The definition says of horizontal matrix that a matrix of order m into n is a horizontal is greater than. So this says that if n is greater than m means number of columns greater than number of rows, then it will be a horizontal. Means if it has 3 columns and 2 rows or 1 row, then it will make horizontal. Let me give you an example. So in this matrix A, it has 2 rows and 3 columns. Means the number of columns is greater than number of rows, so it makes horizontal. Let me give you some other examples as well. We have to follow this rule for n greater than m. Number of rows, number of columns are greater than number of rows. So we have two more examples of horizontal matrix. This is the first example. It is a matrix C which has only 1 row and 2 columns. The number of columns are greater than number of rows, so it is a horizontal matrix. In the other example, which is matrix D, we have how many columns? 4 columns and 3 rows. Here number of columns are greater than number of rows, because number of columns are 4, number of rows are 3. It is a horizontal matrix. I hope you have got an idea of horizontal. Now let's move next type. The next type of matrix is a vertical matrix. This says a matrix of order m into n is a vertical matrix if m is greater than n. It is the opposite of horizontal matrix, obviously, because it has to make a vertical line other than horizontal matrix. So here what is needed, number of rows should be greater than number of columns. In vertical rows greater than, let me give you some examples. This matrix F has 3 rows and only one column. 3 rows are greater than 1. Order is what? 3 into 1. 3 into 1. Because 3 rows and one column. Number of rows are greater than number of columns. That is why it is a vertical matrix. See, it has vertical shape. Let me give some more examples. Vertical. In this matrix G, we have 4 rows, 3 columns. The order of four rows, 3 columns. M is greater than N. That is why G is vertical matrix. Let's move to the next type of next type is square matrix. As you all know, in square all the sides are equal. In square matrix, the number of rows and the number of columns in a matrix will be equal. Okay? A matrix which has equal number of rows and equal number of columns means M is equal to N. Number of rows are equal to number of columns. It will make square matrix. I'll give you 2 rows. It need to have 2 rows and 2 columns, or 1 row 1 column. 3 rows 3 columns. 4 rows 4 columns. Means all those matrices which have same number of rows and same number of columns will be square matrix. Give you proper examples. Here's a matrix H which is of order 2 by 2. Is of order and number of rows and number of columns are equal because it has 2 rows and 2 columns. Okay? It has only one element, so only 1 row and 1 column. Order 1 into 1. Same number of equal to. You can have any number of elements in square matrix. A big 6 rows. This is a matrix A, which is how many rows, whose order is into n is 6 into 6. Same number of rows and same number of columns. 1 2 6 rows, 6 square matrix. Move forward. The last type for today is diagonal. The definition of a diagonal matrix is if all the elements except the principal diagonal in a square matrix are 0, it is called a diagonal matrix. Thus, a square matrix A is equal to Aij is a diagonal matrix if Aij is equal to 0 when I is not equal to j. Don't worry, I am going to explain it in a very detail so that you can understand it. Let me read it first. There are two important things to note here, which are as follows. Number 1, a diagonal matrix is always a square matrix. Number 2, the diagonal elements are characterized by this general form Aij where I is equal to j. Means I row and j is column position. Row position and column position. I shows row position and j shows column position of an element A. A is element. A is element. This means that a matrix can have only one diagonal. Okay, so by this definition, what we understand is if we have a matrix, a square matrix, okay, this is the diagonal of that matrix, and at this diagonal there should be non-zero members. Okay, non-zero members are, let's say, 4 and 100, and the other elements which are non-diagonal, they should be 0, should always be 0. Let me explain this line now. This rule has been followed now in this example, that it will be a square matrix. Now the second thing is that if Aij is equal to 0, Aij will be equal to 0 when I is not equal to j. See, here I is not equal to j because it is first row and second column. Here as well, it is second row and first column. So I is not equal to j. On the other hand, these diagonal elements are where at which position where I is equal to j, because it is first row and first column and it is second row and second column. So the diagonal elements means I is equal to j, where I is equal to j, they will be non-zero members, non-zero elements. Okay, and the positions where I is not equal to j, where I is not equal to j, they will always be 0. All the elements will be 0 there at that. Then, and if a matrix is square matrix, then all these conditions will be followed and the matrix will be made diagonal matrix. Let me give you some examples of diagonal matrix. Firstly, it should be a square matrix. So this is a matrix A, which is square matrix because m into n is 3 into 3 into 3. Square matrix because it has same number of rows, same number of rows, and same number of 3 columns, 3 rows. The second condition is all the diagonal elements. These are the diagonal. Diagonal elements are those which are present at I is equal to j position. But 1 is present at first row and first column. 2 is present at second row, second column. 3 is present at which position? Third row and third column. So they are non-zero elements. This condition is also fulfilled. And all the other elements other than diagonal elements are what? Are 0. So this matrix A is finally called diagonal matrix. Let's have some matrix with only one element can also be a diagonal matrix, because it is self diagonal and it is non-zero element and it is a square. That is why it is a diagonal matrix. This is a diagonal. Non-zero elements. This is non-diagonal, so it has 0 as an element. So this was today's lecture. Let us review it again and then we will continue. So in today's lecture, what we studied was types of matrices. In the previous lecture we studied 4 types of matrices, and then in today's lecture as well we have studied 4 more types of. This is horizontal matrix, vertical matrix, square matrix, and diagonal matrix. In horizontal matrix, the rule is n should be greater than m, means number of columns should be greater than number of rows. In vertical matrix, m should be greater than n, rows should be greater than columns. And in square matrix, m will be equal to n, means number of rows will be same as number of columns. And in diagonal matrix, it should be a square matrix, and the diagonal elements like 4 and 100 in this, they should be non-zero elements. Other elements other than the diagonal elements should always be equal to 0. So these were the 4 more types of. I hope you all have understood it very well, and if you have any query or confusion, you can ask me in the comment section. Mashallah.